Cooling water system. The cooling water system is one of the most important systems of power plant, and its availability predominantly decides the plant site. The high cost of water makes it necessary to use a cooling towers for water-cooled condenser. The cooling water requirement is an open system is about 50 times the flow of steam to the condenser. Even with a closed cooling system using a cooling towers, the requirement for cooling water is also considerably large. This means the 1000 megawatt power plant will require around 100,000 tons of circulating water per day, even with a use of cooling tower. This huge requirement of cooling water is equivalent to the requirement of a big city like Bombay. As a cooling water takes a latent heat from steam in the condenser, the temperature of the water increases. The hot water coming out of the condenser cannot be used again in a closed system without pre-cooling. It is because the hot water coming out of is used again will not be able to absorb the heat as TWO reaches the near Ts. The saturation temperature of the steam at condenser pressure and condenser vacuum cannot be maintained. Therefore, it is absolutely necessary to pre-cool the water coming out of condenser before using it again. Now, condenser water cooling systems. The cooling system which are commonly used in practice according to the availability of the water is listed below. The cooling system is divided in open or a once-through system. Second is a closed system, and third one is a mixed system. Now the closed system is divided into the water cooling or the air cooling. In the water cooling section, the closed system is divided again in the cooling ponds and the cooling towers. In the air cooling system, it is divided as a closed system, direct dry type cooling tower system, or indirect air cooling system. Now, first consider open or once-through or a river water system. In this system, the water is drawn directly from the upstream side of the river and pumped through the condensers and then discharged to the downward side of the river at temperature of 5 to 10 degree increase excess in the inlet temperature. The temperature of the discharge water should be kept within a safe limit to prevent harm to the fishes. The limit of discharge water temperature is specified by the Fishery Board. On one river in England, the discharge water temperature was limited to 25 degrees Celsius. For fishing reason, it is necessary to use a single pass condenser. The arrangement of the open system is as shown that the position of inlet and outlet should be chosen in such a way that there should not be recirculation of hot water, which impairs the efficiency of the condensing plant. Such recirculation is possible in small rivers and canals. Therefore, the distance between the inlet and the discharge point should be as large as 1 kilometer or more. This type of cooling system can be used only where the required quantity of water is available throughout the year. In this, cold water is inside taken with separated or filtered by screens, pumped to condenser, and discharge is taken out and given back to the river again. Now, once through system, when sea or tidal river water for cooling. The plant on the tidal water using a water from the tide or sea have a special problem in construction of cooling water system in avoiding the recirculation of the cooling water from the outlet back to the intake. In many plants, the intakes and outlets are separated as 3 kilometers. In the tidal water, the water flows in one direction for some time and another direction for some time. Therefore, it requires a special arrangement for the change in flow direction. The section taking water from the river or tidal source usually have the ends of both section and discharge pipes submerged below the lowest recorded tidal level. The water circulation system will operate at all times and at all states of tide if the distance between the lowest level and the highest point of a circulating water system does not exceed the 10 meters. Now, a closed system. When enough quantity of water is not available for cooling requirement from the river, then the closed type system is universally adopted. In closed system, the hot water coming out of the condenser is cooled either by spraying in a pond or passing through the cooling tower instead of discharging to the downward side of the river. The quantity of water required is collected from the river during the flood period, and when sufficient water is available with the required purity, and same water is used again and again for condenser by passing through the cooling towers. Such arrangement of cooling system is more efficient. With this system of cooling, also an external source of water is needed to replace the tower evaporation and carry over losses. The quantity of water lost by evaporation and carry over varies between the 2 to 5% of that circulated water depending upon the design of tower. Even a 5% of makeup water is appreciable quantity, that is 5,000 tons per hour for 1000 megawatt capacity plant. Therefore, the power plants using a closed cooling system obtain their makeup water from rivers, and the similar intake arrangement is adopted on the smaller scale as used for open system. Now, mixed system. A mixed type cooling system uses a river water as well as cooling tower simultaneously. This system embodying the river and the cooling tower overcomes the difficulty of recirculation and meets the requirement of the fishery board on the fairly small river. The arrangement of this system is as shown in figure, which is taken as a condenser discharge is fed to the cooling tower, and the cooling tower discharge is then given to the river flow. Now, in this way, the water discharge, the part of the water from the condenser is discharged directly into the downstream of the river, and a part of water is pumped to the cooling tower, where it is further cooled and then discharged to the downward side of the river. In this way, the water discharge to the river is maintained at suitable temperature and recirculation troubles are eliminated. The advantages of this system are listed. The size of cooling tower can be reduced where the side area is limited. The quantity of cooling water required is reduced as recirculation is eliminated. The turbine plant efficiency is increases. The saving in discharge pipework and pump tower power is possible as the towers are situated at considerable small distance from the station. This system should be adopted only when there is a possibility of recirculation and it is necessary to meet the requirements of a fishery board. Another type of system where the river water and the cooling tower both are used simultaneously are same when the both uses the same OTC tower, like the condenser takes the cooling water from the river and it is discharged to the river again. After that, the cooling tower is also taken the water from the discharge of the condenser and it is used as a combined condenser arrangement. Now, the steam condensing plant, when adequate cooling water is not available for whole of the year, this system is used as an open or closed system. Sometimes the adequate water in a river or a canal is not available throughout the year for once through cooling system. Many times the river can supply adequate water 80 to 90% period of the year, but it runs dry during the remaining period of the year. Therefore, under such circumstances, once through cooling system can used only 80 to 90% of the year. For the remaining period, closed system must be used. In this type of cooling system, the cooling towers are used only during the period of inadequate water supply. The example of such case is a Pinky power project at Kanpur. For 11th month, normal once-through system is used for condenser cooling, and the remaining 1 month cooling tower are used when the canal runs dry. The water from Ganga's canal is pumped with the help of three pumps, each having the capacity of 80,000 cubic meters per hour. The water, after passing through the condenser for cooling, is discharged to a downstream of the river as shown. During the time when the canal is closed, a closed circulation system is used. The water coming out of condenser is passed through the cooling towers having a 6 sets as shown in figure. Makeup water during the canal closure is obtained through the makeup water pump. The seepage water in the canal will be sufficient to provide this makeup. Now, water cooling methods and mechanism of cooling. The cooling of water coming out from the condenser is done either by cooling pond or cooling tower. The hot water gets cooled when exposed to the atmospheric air. That is because the atmospheric air has definite capacity to absorb water vapor at given temperature, and the heat required for water vaporization is taken from the remaining water and water gets cooled. A detailed heat transfer mechanism between the hot water and atmospheric air is as the mechanism of cooling. Whenever the moisture is exposed to air, either in the form of droplets or a sheet, part of it is evaporated as the liquid changes to vapor. The heat required for evaporation is taken from the remaining water and water gets cooled. When the hot water comes in contact with air, the heat from the water to the air is transferred as a sensible heat as water temperature is higher than the air temperature. The evaporation heat as WBT of air is lower than the DBT, that is dry bulb temperature, and the wet bulb temperature of air. The difference between the DBT and WBT indicates the capacity of air absorbing the water vapor. The rate of heat transfer between the hot water and air depends upon the initial temperature of hot water, temperature of atmospheric air, relative humidity of the air, and the movement of air and solar radiation. The higher the DBT, lower the WBT. The higher the air movement gives the better cooling of water. The condition of atmospheric air and the air after cooling the water coming in contact are presented in the psychometric chart. In this, the net heat absorbed per kg of air from the hot water is given by H2 minus H1. As the figure, on average, about 80% of total heat lost by the water is removed by evaporation and 20% by the sensible heat transfer. The total heat transferred is equal to heat of evaporation plus sensible heat, that is delta H is equal to delta H2 plus delta H1. The cooling tower is an evaporative cooler. In tower, a large surface area of water is exposed to the air that is passing through the tower so that some of the water will evaporate into air. The difference in the vapor pressure between the saturated water and the unsaturated air is what triggers this evaporation. The heat energy necessary for evaporation is taken from the water itself and lowers the temperature of the remaining water. In all thermal power plant using a steam as a working fluid, either a cooling pond or cooling tower are used for condenser water cooling. The constructional details and operating features are discussed below. The warm water coming out of the condenser rises to the surface of the body of water to which it discharges, and because of its lower density, it spreads in a thin film on the surface, which helps for evaporation and cooling of water. A few plants depend entirely on such surface cooling without using sprays or cooling tower. This method of cooling is proves feasible where the enough water surface is naturally available, like lake, ponds, sea water surfaces.